Hi, welcome to our next level 3 integration video. We are nearly there. We continue talking about differential equations in this video, and we go straight into an example. We're going to solve the differential equation dy over dx is equal to x. Now, the way we showed you to do it in the last video was this. We integrate the left-hand side with respect to x, we integrate the right-hand side with respect to x, and the left-hand side dy over dx integrates back to y, and on the right-hand side x integrates to x squared over 2. We add 1 to the power and divide by 2, and then we plus our constant c. So we get the solution y is equal to x squared over 2 plus c. This is called the general solution because we don't have any further information to find out what c is to get the particular solution. Right, well, I'm going to show you a different way to solve it, and I'm going to show you the proper way to solve it. And the technique is called separating the variables. It's a bit of a shame because most calculus students, most students who've done calculus won't get this far, won't be attempting these difficult questions in the exam, and may not see this video. Hence, they won't really know what's going on because this is actually really what is happening when we integrate. All right, let's write down dy over dx is equal to x. I'm going to times both sides by dx, so I get dy is equal to x times dx. Now that dy by itself is just 1, so 1 lot of dy is equal to x times dx. Right, now I'm going to integrate both sides, but notice what's happening. On the left-hand side, I'm integrating the number 1 with respect to the y variable. And on the right-hand side, I'm integrating the x with respect to the x variable. When I integrate on the left, a number 1 integrates to 1y. Because I'm integrating with respect to the y variable, a y comes back. Remember, when we integrate a number by itself, the letter comes back. Now, I've introduced a constant, not c, I'm calling it d for now. Just hold on, we'll explain why soon. So I've got 1y plus d. Now 1y is just y plus d. Now when I integrate the right-hand side, we're going to integrate with respect to x. We're going to integrate and get x squared over 2. We add 1 to the power, divide by 2, and plus our constant e. Again, don't stress it's not c right now. Now, here's what I'm going to do. I'm going to take that constant d. If there is one on the left, I'm going to put it over on the right and make it a subtract. And the e subtract d will give me some kind of number, whatever number e minus d is, and I'm just going to call that combined number c. So I get y equal to x squared over 2 plus c. Now, this technique is called separating the variables. And what I ended up doing was split everything to different sides. So I had all my y variables and things on one side to do with y, and all my x variables and things to do with x on the other side. And then I integrated both sides with respect to y and x separately. Okay, it may seem a complicated way, but let's show you why and how useful this technique is. Let's go on to example 2. Solve the differential equation dy over dx is equal to 2 times x times y minus y by separating the variables. Right, let's write down the question, and here we go. First of all, there's a y common to both, so let's factorize out the y. Right, now let's times both sides by dx. Now let's divide both sides by y. Right, on the left-hand side, I'm just going to write it as 1 over y times dy. Right, let's put it up here on the other side. Now I'm going to integrate. So I'm going to integrate the left-hand side with respect to y, and I'm going to integrate the right-hand side with respect to x. So when I integrate 1 over y, I'm going to get natural log of y plus some constant d. When I integrate 2x minus 1, I'm going to get x squared minus x plus some constant e. And finally, I can take the two constants d and e and put them on one side, normally on the right, and make it a constant c. So my general solution is natural log of y is equal to x squared minus x plus c. That's it. Thanks for watching.